Hello guys, welcome back to this concept-based YouTube channel. Today we're going to discuss Class 9 Maths Chapter 1, Exercise 1.5. So the first problem that we have is, we have to classify the given numbers, whether they belong to rational number or irrational number, okay? So 2 minus root 5. So root 5 is a rational number. If we subtract root 5 from a rational number, that is, if we subtract irrational number from rational number, then we're going to get irrational number. Okay, so is it clear? If it is clear, then we are going to move to the Roman number 2. So in Roman number 2 we have 3 plus root over 23 minus root over 23. Okay, 3 plus root over 23 minus root over 23. Okay, plus minus, the values are same. If we subtract this one, then we will get 0. So the remaining number that is left with us, that is 3. So 3 is rational number because as we get expressed in the form of p by q, and q does not equal to 0. Q is not equal to 0. Okay, because of that 3 is rational number. That means this expression is irrational. This expression belong to rational number. Okay, after a simplification we got 3, and 3 is rational number. Okay, then let us move to this Roman number 3. In Roman number 3 we have 2 root over 7 divided by 7 root over 7. So if we divide root over 7 by root over 7, then how much will we get? That is root over 7 times 1, that will give you root over 7. We can cut this one. After cutting this, or after reducing this fraction, or after reducing this, how much will we get? That is 1. So 2 times 1, that will give you 2, and 7. Okay, 2 by 7. So if you divide 2 by 7, then you will get some decimal expansions. The decimal expansions that you are going to get, that will be non-terminating, repeating, or recurring decimal expansions. So this kind of decimal expansions, we call it, or fall under, or came under the term rational number. Okay, thus 2 by 7 is rational number. Then let us move to this Roman number 4. In Roman number 4 we have 1 by root 2. So root 2 is irrational number, and 1 is rational number. So if we are going to divide rational number by irrational number, then the outcome will be some decimal expansions, and these decimal expansions will go on like this. It will not terminate. Okay, it will not terminate, and it will go on like this. And the decimal expansions is non-recurring. Okay, non-recurring, non-terminating, non-recurring. So this kind of decimal expansions that we are going to get from this, we call is term as irrational number. Okay, or came under the term irrational number. All right, then let us move to this Roman number 5. So in Roman number 5, what do we have? That is 2 pi. So 2 pi is a rational number. So 2 is rational number. If we multiply a rational number with rational number, then we will get the same, that is irrational number. Okay, then let us move to this second question, or next question, that is question number 2. In question number 2 we get simplify each of the following expression. So in this, let us discuss the first Roman number, that is 3 plus root 3, 2 plus root 2. Okay, so in order to solve this, let us take, first of all, let us take this one. Okay, so this one. So let us write the same as the question, and let us take first of all root 3. Okay, this 3. Then let us multiply this 3 with this number. So 3 times 3, that will then plus, here it will be plus, here it will be 3. So you have to multiply root 3 with this number. Okay, this. Then 3 times 2, that will give you 6, and 3 times root 2, that will give you 3 root 2. Okay, plus 3 times root 3 into 2, that will give you 2 root 3, plus into plus, that will give you plus root 3 into 2, that will give you root 6. Okay, so this will be the answer for this Roman number 1. Okay, then let us proceed to this Roman number 2. In Roman number 2 we have 3 plus root 3, 3 minus root 3. Okay, here let us assume that, let us take this 3 as the values of a, and this as the values of b. So a plus b, a minus b. So by using this expression, we can use one formula, that is here a square a minus b a plus b. Okay, actually the given expression is in the form of a minus a plus b a minus b. Okay, so what is the expression that is equal with this? That is a square minus b square. Since the given expression is in the form of this, so we are going to express in this form. Okay, so what is a? That is 3. So what is here? Square. So 3 square, then root 3 holding square. So square and root cancel, that will come out 3. 3 square, that will give you 9. 9 minus 3, that will give you 6. Okay, is it clear? Okay, then let us move to the next problem. That is Roman number 3. In Roman number 3, let us take this one as values of a and this one as values of b. Now we can assume that a plus b holding square. Okay, now we are going to use a plus b holding square formulas. So what is the expression? At root 5 plus root 2, it is in the form of this. Okay, we have to express in this form. Now in order to express in this form, let us first take this one. So a square, that is root 5 square, plus 2. Okay, what is the values of a? That is root 5. And what is the values of b? That is root 2. Okay, plus. So what is the values of b? That is 2. Here b square. Okay, let us put some square. So square and root cancel, and then it will come out 5. So 2, 5 times 2, that will give you root over 5, and 2 root 2, that will give you root over 10. Okay, plus. So square and root cancel, that will be 2. So 5 plus, if you bring this 2 on that side, okay, then you have to add with this, then 5 plus 2, that will give you 7, then plus 2 root over 10. Okay, so this will be the answer that we are going to get in Roman number 3. Then let us proceed to this Roman number 4. In Roman number 4, we have root 5 minus 2 and root 5 plus root 2. So let us take this root 5 as the values of a and this root 2 as the values of b. So by using this expression, we can use one formula, that is a square minus b square. The given expression is in the form of this. Okay, so we are going to use this formula in order to express this. Okay, so what is the values of a that we took? That is 5. Okay, here it is square, here it is square, so we have to put square here, minus. Okay, and what is the values of b that we are taking or we took? That is b. So what is the values of b? That is root 2. Here it is square, so we put square and root cancel, that will come out 2. Square and root cancel, that will come out 5. 5 minus 2, that will give you root 3. 5 minus 2, that will give you 3. Okay, is it clear? Then we are going to proceed it to Roman number 5. In Roman number 5, we have 3 root over 5 minus 4 root over 3 holding square. Okay, let us assume this value as a and let us assume this value as b. Okay, here the given expression is in the form of a minus b holding square, and the outcomes of this will be a square minus 3ab plus b square. Okay, now we are going to express this given expressions in the form of this. First, actually we assume the values of a as 3 root over 5. 3 root over, here it is a square, so we are going to take 3 root over 5 holding square. Okay, minus 2 into ab. Where is the values of a? 3 root 5. Okay, into what is the values of b? That is 4 root 3. Okay, plus. Okay, so what is the values of b? That is 4 root 3. 4 root 3 holding square. Okay, actually we are using these formulas. Now 3 times 3 square, that will, here it will be 3 square, since inside this bracket it is 3 and root 5. Okay, 3 square into root 5 holding square, minus 26. 2 times 3, that will give you 6, and 6 times 4, that will give you 24. 5 times 3, root over 5 times root 3, that will give you root over 15. Okay, plus here it will be 4 square, and here it will be root 3 holding square. Okay, since square is for both, that is 4 as well as root 3. Alright, then let us cut this root, this square and root, then let us cut even in this side. Okay, here 3 square, that will give you 9, and here it will be 5 minus, here it is 24. Okay, 24 root over 15 plus 4 square, that will give you 16. Here this dot, that means multiplications. Okay, by using dot we denote multiplication, so 16, here it will be 3. So 16 times 3, that will give you 48, and minus 24 divided by root over 15. Okay, here 9 times 5, that will give you 45. All right, then let us bring this plus 48. Okay, in that side, that means 45 plus 48 minus 24 root over 15. Okay, so if you plus this, how much will you get? That is 93 minus 24 root over 15. Okay, actually if you want to stop it up to this, then you can stop it, but if you want to expand it more step, that is one step, then you can use this one by taking common. Okay, 3 times 31, that will give you 93, minus into plus, that will give you minus, and 3 times 8, that will give you 24, and 24 into this will give you 24 root over 15. Okay, is it clear? If it is clear, then we are going to proceed it to Roman number 6. Okay, if it is clear, let us proceed to Roman number 6. In Roman number 6, we have root 7 minus 6 and root 3 minus root 7. Okay, so here the first question, how should we solve this one? So first let us take this one, and we have to multiply this number with this. Okay, then here it is minus, let us put minus here. So here it is 6, let us write 6 here. Okay, then we are going to multiply this 6 with this number. Okay, here it is 6, here it is 6, we are going to multiply with this number. Okay, now root 3 times 7, root 7 times root 3, that will give you how much? Root over 21 or root 21. Okay, minus plus minus root 7 into root 7, that will give you root 7 holding square, minus 6 times root 3, that will give you minus 6 root 3, minus into minus, that will give you plus, and 6 into root 7, that will give you 6 times 6 into root 7, or 6 root 7. Okay, then here it is root over 21 minus square and root cancel, that is minus 7 minus 6 root 3 plus 6 root 7. Okay, so let us keep all the root in one places. Root 21 minus 6 root 3 plus 6 root 7. Okay, and let's keep this one, this number as in that side. Okay, minus 7. All right, so this is the answer that we got from solving Roman number 6. Okay, is it clear? If you have any kind of doubt regarding about this, please let me know in the comment section. Okay, then let us proceed to Roman number 7. So what do we have in Roman number 7? That is 2 plus root over root 6, 4 plus root 6. So even in this, we are going to proceed to the same process that we use here. Okay, here. Okay, the process that we use here, we are going to use even in solving Roman number 7. So what do we have in Roman number 7? That is 2 plus root 6, 4 plus root 6. First, let us take this root 2, and let us take this 2. Okay, 2. Then let us multiply this 2 with this number. Okay, 4 plus how much? Root 6. Okay, now plus, let us take this plus. Then root 6, let us take root 6 here. Then what should we are going to multiply this root 6 with? Okay, that is 4 plus root 6. All right, then 2 times 4, that will give you 8, and 2 times root 6, that will give you 2 root 6. Then root 6 times 4, that will give you 4 root 6, plus root 6 into root 6, that will give you root 6 holding square. Okay, square and root cancel. Now 8 plus, let us take this root 6 as common. Okay, then what is left with this? Root 6 times 2, that will give you 2 root 6, plus root 6 into 4, that will give you 4 root 6. Okay, now so if we cut this one square and root that, then it will remain 6. Now let us bring this 6 on that side, in that side. Okay, here it will be 6 plus root 6. So how much will it be? 2 plus 4, that will give you 6. Okay, 8 plus 6, how much will it be? That is 14. All right, so if we multiply this 2, then it will be 6 root 6. All right, then if you want to stop it here, then you can stop it, but if you want to expand it one more step, then you can do it by taking common. Okay, so here let us take common. 2 times 7, that will give you 14, plus 2 times 3, that will give you how much? 6. Okay, here let us put root 6. If you multiply this with this, then you will get this 6 root 6. Okay, then if you multiply 2 and 7, you will get this. Okay, 14. So you just expand it by taking common. Okay, But if you want to stop in here, you can stop it. If you want to expand it one more step, then you can expand it by taking 2s a common from this. Okay, so this is all about the problem that we are going to discuss today. So in the next problem we are going to proceed it from question number 3. Okay, so as we discuss all this problem, you may find some difficulties in understanding. Please comment down below, okay, if you have any problem. Then that's all for today. Thank you. Have a nice day.